So tonight's lesson is on exponential growth and decay. Exponential growth is, you use that whenever you're talking about population growth, or we could show it using sugar crystals, the way sugar crystals grow. And it's when something grows very quickly. First it grows very slowly, like this graph is growing very slowly, and then all of a sudden it just grows really quickly, shoots straight up. Its equation is represented by this formula right here. The difference between exponential growth and decay is the growth factor, what they call the growth factor. And for growth, you do 1 plus the percent rate. Okay? 1 plus the percent rate. In exponential decay, I'll show you later. But as long as it says grows or increases, let me write those words down. Grows or increases or interest, you're going to use exponential growth. Okay, so this one is spent at restaurants and money spent at restaurants, and it says that it has increased, so we're going to use the exponential growth equation. And it says the amount of money spent at restaurants in the United States has increased about 7% each year. In 2005, about $360 billion was spent at restaurants. So, our question is, how much will be spent at restaurants in 2015? We need to write down our formula first, and if you remember from the last slide, it's y equals a times b to the x power. And a is going to be our initial amount, and b is going to be our growth factor, and x is going to be our number of periods. Meaning, if it said it's growing this much every year, and they're asking for like 12 years, you would put 12 where x is. So, we have to find all our information out of our problem. And let's see, the initial amount was in 2005, and it says about $360 billion. The growth factor is always going to be, and you got to remember now, it's growth, so it's going to be 1 plus our rate. So here's our rate, so our growth factor is going to be 1 plus that. Now you don't do 1 plus 7, you do 1 plus the decimal form of it, so that's going to be 0.07. And then our x is how many times it grew. So if what it says here is 7% each year, and this says in 2015 from 2005. So how many years is it between 2005 and 2015? It's 10. So we're going to say that our x is 10. Okay, and then you just plug all of that in. So that's going to be y equals 360. And I know you're thinking, Ms. Richards, that's billion. Well, I know it's billion, and later on I'll put billion on it. But instead of having to write all those zeros right now, I'm just going to wait and put them on the end. So that's 360. Growth factor is 1.07. Times 1.07. And then x is 10. So right now what I want you to put in your calculator is 1.07 to the 10th power equals, now don't take that out of your calculator, leave it in there, then say times 360. And I got about, because it was a decimal, oops, 708 billion. And of course, if it says growth, it's got to be bigger than the number you started with. So if you didn't get something bigger, it's not right. Okay, here's your got it question. What I want you to notice is this says that it increased. So that's your clue that you're going to use growth. And then I'll write your formula down for you. So y equals a b to the x power. Don't forget to add the growth factor to 1. Okay? Pause it. Catch up with me on the next slide. Okay, a special form of exponential growth is called compound interest. So, hold on just a second. Compound interest. If you have money in a savings account somewhere, you earn compound interest on it. If you buy a car, you're paying compound interest on it. And what they do is, instead of just doing interest on the whole lump sum, they do interest every single month or every single week. And whatever they tell you they're going to do interest by is called the periods, or the number of times interest is compounded per year. So if they say, well, we'll give you interest monthly, then that would be 12. If they say weekly, that would be 52. Okay? So here's all the different parts. A is what's going to be your answer for the question, and P is the money you started with. R, and since it's growth, you always have to do the 1 plus. So that's already in the formula for you. R is the annual interest rate, and you got to change that to a decimal. And then you have to divide by the number of times they're going to compound the interest. And then you raise it to the exponent, the number of times they're going to compound the interest times t, the number of years. So I'm going to rewrite that formula right here under my problem. And we're going to do this problem with the compound interest formula. So I've got my R that I need to change to decimal. I've got my P. And I've got my T. Where's my N? Suppose that your friend was born, your friend's parents deposited $2,000, P. I'm going to label all this. P. 4.5% interest is R. Compounded quarterly, there you go, quarterly. That's my N. How many quarters are in a year? Same amount of quarters that are in a dollar. So 4. I'm going to go ahead and write that. N equals 4. What will the account's balance be after 18 years? And that's my T. So I just want you to plug it all in and use your calculator. As long as you can figure out what goes where out of this word problem, and you know how to use your calculator, you'll be fine on these questions. So P is 2,000. Oops. So 1 plus R is 0.045. You always move the decimal 2 places to the left. That's where I'm getting that number from. My N is 4. And my exponent's going to be 4 times 18. Now, if you're not careful, you're going to mess this up just by putting it in your calculator, because some of your calculators do not do the order of operations for you. So you're going to have to think about the order of operations as you put it in your calculator. So I'm going to do parentheses first. So in your calculator, I want you to do the division and then the addition. So in your calculator, do 0.045 divided by 4 equals plus 1 equals. Hopefully you got 0.01125. So it's going to be 2,000 times 0.01125. Now I have to do the exponent, but I can't necessarily do the exponent until I know what 4 times 18 is. So let's do some scratch work on this one. Let's do 18 times 4 just so we can practice multiplying. That's going to be 32. So you write the 2, carry the 3. And that's going to be 4 plus 3 is 7. So 72. 18 times 4 is 72. And in case you haven't noticed, I'm using different software to make this video. And I'm learning it too, so bear with me while I figure this whole thing out. So it's going to be to the 72 power. Now what you can do is put all of this in your calculator. So you're going to do the exponent first. So let's do 0.01125. Put that in your calculator. 0.01125 to the 72 power equals times 2,000. Okay, so here's your guide at number 2 question. I've written the exponential decay, the compound interest formula on there for you. And I'm not going to tell you what everything is, but you can go back to another part of the video if you want to. Okay, so the next thing we have to do is exponential decay. I've already kind of shown you what you need to watch out for. It's the same as exponential growth, the exact same formula, except the B, you have to remember that that's going to be the decay factor, not the growth factor. So you have to do 1 minus the percent rate. How do I know if you need to use growth or decay? Well, I told you the keywords for growth and the keywords for decay are words like decrease and decline. Alright, so last example for us, the kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. What is the approximate pressure at an altitude of 3,000 meters? So, I'm going to write down my decay formula. Y equals A times B to the X power. So my initial amount is 101 kilopascals. For every 1,000 meters it increases in altitude, the pressure decreases. So you might get confused here. It's got increase and decrease. But we're talking about pressure, and that's what's decreasing. So that's the decay. And there's the rate, 11.5%. And they're talking about how many times does it decrease. So it says 3,000 meters. That's not it. It's for every 1,000 meters it increases. And now it's 3,000. So how many times did it increase? 1,000, 1,000, 1,000. So that's 3 times. So when you plug your stuff into your formula, you're going to get 101 times 1 minus 0.115 to the 3rd power. So let's practice putting this all in our calculator, not having to pick up our pencil. Write down anything, not having to remember any numbers. We're just putting it all in the calculator. You're going to do order of operations for your calculator. So you're going to do inside parentheses 1 minus 0.115 equals, now don't touch it after that. Leave that number you get in the calculator. You want the calculator to remember it for you. So now take that number, push your exponent button, and raise it to the third power, equals times 101. And I've got 70, about 70 kilopascals. I don't know the abbreviation, but I'm going to put kp. Okay, and if it's growth, you know it has to go up, but if it's decay, it has to go down, so it has to be less than your initial amount. And here it was 101, and I have 70, so that's a pretty, that answer makes sense. Alright, here's your last guided question. I do want you to do both A and B, so you'll really have 4 questions. Pause the video. On the next slide, I'm going to tell you how you can contact me if you have any questions. Alright, email me, Remind101, chat with me. You can get up with me somehow on Twitter and Instagram. You can message me on Facebook. Please do not forget to participate in the discussion on Facebook or Twitter or Instagram. Okay? Either one. Not all 3, but just one of them.